This is the teacher summary for Unit 6, Quad Polygons and Motions, Lesson 6.1, Rectangles, Rhombi, and Squares. Let's look at those family trees that you started earlier. This is your ringlet reference card. Basic qualities of all quadrilaterals are two things. One, all quadrilaterals have four sides. Also, angles sum 360. Every single quadrilateral, those are the two main components. Parallelogram has 5 qualities. First and defining quality is the fact that opposite sides are parallel. Second one is the fact that opposite sides are congruent. Third quality is opposite angles are congruent. Fourth quality is that consecutive angles are supplementary. That means angles that are next to each other add up to 180. Last one, the diagonals, just write diags, bisect each other. They do not bisect the corners, but they do bisect each other, which means if you were to draw in these two diagonals from corner to corner, that this would be the midpoint going both ways. Those are the 5 qualities of a parallelogram. You need to have this memorized. The quickest way to remember this is remember this acronym, OCD. OCD, opposite, 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 consecutive, diagonal. Say it out loud. Opposite, 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 consecutive, diagonal. Now those 5 qualities of a parallelogram, both a rhombus and a square have those qualities, which means both the rhombus and a rectangle are descendants of a parallelogram. So a rhombus and a rectangle have all the qualities of a parallelogram. So they are a parallelogram plus additional qualities. A rhombus has all the OCD qualities plus these 3 additional qualities. 1, it has 4 congruent sides. So not just opposite sides congruent, but all the way around, 4 congruent sides. Next one, draw in the 2 diagonals using a straight edge if possible. The diagonals are perpendicular, which means they create a right angle. And the diagonals bisect the corner angles. That's really important. That does not happen in a parallelogram. The diagonals bisect these corner angles. So hatch marks, cuts these angles in half. Rectangle has all the qualities of a parallelogram, the OCD qualities, plus 4 right angles. Take a straight edge, draw in the diagonals. The diagonals are not perpendicular, but the lengths of the diagonals. So the length of this diagonal, I'll do it in light green, compared to the length of this diagonal, the lengths of the diagonals are congruent. Now, since it also, that's a midpoint, that means all 4 of those pieces are congruent. I'd like you to mark them congruent. And I'd like you to shade one triangle here. Just shade it. Really important to watch out for this. That is an isosceles triangle. So keep this in mind when you're working this, that when you have a rectangle, you're going to end up with 4 isosceles triangles. Now, if a rhombus and a rectangle get married and have a kid, they have a square. And just like children have the characteristics of both parents, a square has all the qualities of both a rectangle and a rhombus. So all these qualities we just listed, a square has them all. So it has 4 equal sides like a rhombus, and 4 right angles, and diagonals that bisect the corners, and diagonals that are perpendicular. So a square has all the qualities of both a rectangle and a rhombus. Keep this out for easy reference. Now we're going to do one example problem together on page 3 of your homework. I'm going to do one example here. It says a rectangle, we're going to do an example with a rectangle, has all the qualities of a parallelogram, which is OCD qualities, and these 2. The diagonal lengths are congruent, and you have 4 right angles. Now it says in the below we have a rectangle. We're going to find all possible angles, side lengths, and segment lengths. All possible. I call these squeeze the sponge problems. So our goal is to find everything possible. So keep asking yourself, when you think you're done, ask yourself if you think you have found everything. That's very important. Okay, let's start with the easy stuff. Easy stuff. If this is a parallelogram, we know opposite sides are equal. So if that's 10, that's 10. That's 24, that's 24. If that's 13, this is 13. And then because that's a midpoint and the diagonals are equal length, that means this is 13 and this is 13. Okay, we just found all segment lengths. That was easy. Now what else did I ask you to find though? I also asked you to find angles. But there's nothing there. Let's look at what we do have though. It's always important to ask yourself what you can do. What can you do? And the minute you notice you have a right angle, you should automatically go get your best friend out. Okay, so let's take a look. We need to find angles. I'd like you to pull out one right triangle. Right triangles are what I call the key to the universe. Right triangles give you almost anything and everything you need. So if you see a right triangle, you need to learn to be able to work with it. So we're going to pull this out here. Right triangle. There's your right angle. Let's pull your numbers down. That's 10. From here to here, that's 13. Trace, that's 13. That makes this 26. And this length is 24. Our job is to find some angles here. All you need is one. So I'd like you to sweep this one right here. If you have a right triangle, take a look at the best friend here and ask yourself, what can you do to find angles? Regular SOHCAHTOA we use for sides. It's inverse SOHCAHTOA that we use to find a missing angle. So we're going to be right over here on this side using one of these inverse SOHCAHTOAs. Let's see what we have here. We have an opposite. If we're going to use that angle, that's adjacent. And of course this is the hypo. We have all three sides, so honestly we could choose. We can choose actually any one of these three. Inverse sine, inverse cosine, or inverse tangent. If I have a choice, I just naturally choose the first one, which is inverse sine. So we're going to choose that one. So we're going to do inverse sine. Opposite over hypo is going to give us our angle theta. That's going to be our angle theta right there. So we go inverse sine, our opposite, circle plug chug. Opposite, pick it up, is 10. Our hypo, pick it up, is 26, equals that angle theta. Let's get our calculator out. So I'm going to use inverse sine 10 over 26. So we do 10. In my calculator, it's 10 divided by 26 equals. Then you hit inverse. Notice we get the inverse sine -1. Click. We get 23. Round to the nearest whole number for degrees, 23 degrees. So it is 22.6 degrees, which is approximately 23 degrees. That is our theta. Now, as soon as we found that, our goal is to find all other angles. So let's come back up to our rectangle. And we just found this one is 23 degrees. Keep in mind some of the properties of a rectangle. One of the most important is that you have 4 right angles. So I'd like you to physically sweep that to get this yellow angle. Of course, is 90 minus 23. And we get 67. Now remember, opposite sides are parallel because we also have a parallelogram here. So let's do opposite sides parallel with the little arrow feathers there. And if opposite sides are parallel, draw your armpits of the Z. We just found 23's up here as well. And we could also do opposite armpits of the Z going this way. That means this right here is 67. But wait, there's more. There's so much information you get just because we know it's a rectangle. Remember I told you to watch out for isosceles triangles? So if you have 2 equal sides, you have 2 equal angles. So if that's 23 there, that's 23, and you just walk it around now. We have 67, 23, 23, 67. You think you're done? You are not done because we have a triangle here, and we know triangles add up to 180. So we can get this angle right here. We're going to add 23 plus 23. Of course, we get 46. We're going to do 180 minus 46. We get 134. And you have here bow tie angles, so that's 134. Sweep that, that's 180. To get this last green angle here, we're going to go 180 minus 134. And of course, we get 46. Bow tie angles 46. Now look very carefully. Ask yourself, are there any sides or angles left? And the answer is no. So we have now managed to do what I call squeeze the sponge, which is to find everything possible. When you're given a rectangle, you have tons of information. Watch out especially for those right angles.